Bismillahirrahmanirrahim. Today we'll be solving or discussing example 18.7 and solving practice for problem 18.7. And this is on the request of Melania from University of Namibia. Let's see how to solve it. This is the question. The example, find V0t in the circuit. For VIT, this is given. So this is the circuit and the input voltage is given. And we have to find the output voltage VOT. Simple question, but with a little bit of a trick. So let's see. First of all, as you know, we got to convert the circuit into a frequency domain or phasor domain to solve it easily. And this is from 18.2 table. E minus AT UT in frequency domain or Fourier domain will be 1 over A plus j omega. So we'll use this formula to convert this one. So the input signal will become 2 and e raised to the power minus 3t will become A plus j omega. 3 is A, so 3 plus j omega. And then we have to convert the capacitor 1 farad into frequency domain as well. We know the formula 1 over j omega c, plugging in the value. So 1 over j omega is the frequency domain representation. So circuit in frequency domain or phasor domain or Fourier domain, just keep in mind that they are the same things, not much difference. So we have just replaced this with the phasor value and the capacitor also with the phasor value. Now, there straight away we could solve the output as I have shown here, but I will follow the book because book is following slightly different method. But just for your knowledge, you know, V out can be this voltage divided between these two and multiply by 1 over j omega. So V out is V in divided by the 2 plus 1 plus j omega and multiply by j omega. And you can then put in the value of Vi omega, which is 2 divided by 3 plus j, and solve. In solving, you get this answer. But I'll follow what the book has done so you don't get confused. Let's go to the book method. So he is using the transfer function, and we know the transfer function is y over x, that means output divided by input. And from here, we can write the output to be h omega x omega. So we'll follow this. First of all, V out, as we did in the previous slide also, V out is V in divided by these two and multiply by 1 over j. Now from here, we move Vi to the left hand side, so we get out over in or h omega. So bringing this here and this up 1 over j and divided by 2 plus 1 over j. And then simplifying, we take the LCM here, j omega, we get this term, and j omega gets cancelled. That is 1 divided by 1 plus j2 omega. And this is our h omega because V out over V in is h omega. And now we'll use this formula to find V out. So V out is V in h omega. Plugging in the value of V in, this is V in, and we found h omega. So we get the same answer as the previous slide we have got. So this is the answer that we have to now further solve. Now, since there are two factors in the denominator, we have to use partial fraction method to resolve this into two parts. And I hope you remember this. We have to take two variables here, a and b. A divided by the first term and b divided by the second term. And now again, you have to recall the residue method, although I'll repeat it here. The residue method says that to find A, we have to multiply V omega by the denominator of A. So denominator of A multiplied by V omega. And the condition is that we put this equal to 0. So when we put 3 plus j omega equal to 0, j omega becomes minus 3. So this is the condition that we'll apply. And now we'll put in the value of V omega here. It will be 3 plus j omega, and this is our V omega. Now 3 plus j omega and 3 plus j omega will get cancelled. So we get 1 divided by this term 0.5 j omega. And the condition remains j omega is equal to minus 3. Now we'll plug in the value of j omega here. So it will be 1 divided by 0.5 minus 3. So j omega is minus 3 here. And solving, A becomes to be minus 0.4. Same technique for B. The denominator of the B we'll use for multiplying. So we are using that to multiply with V omega. And from here, the condition we get, putting this equal to 0, the j omega is equal to minus 0.5. So now we'll put in the value of V omega as we did in here, putting in the value, and now these two terms will get cancelled. So we're left with 1 divided by 3 plus j omega, and the condition, plugging in the value of j omega and solving, P comes to be 0.4. So resolving the partial fraction, we get this answer. A is minus 4 and B is 0.4. And now we are ready to take the inverse Laplace transform. So again, we go back to the table. Now we have in this form, we'll go back to the time domain. So inverse Fourier transform, and we have to take inverse Fourier transform. And from here you can see minus 4. This term 1 over 3 plus j omega, 1 over a plus j omega. So we write e raised to the power minus a or e raised to the power minus 3t ut. And same here, e raised to the power minus 0.5 t ut. And if you want, you can take 4 common, write the positive terms first and then the negative term. So this should be your answer. Okay, now we'll also do a practice problem which is exactly similar. The only difference is that in the previous one, there was a capacitor. In this case, there is an inductor. And the output here is being taken across the resistor, not the inductor. We follow exactly the same technique. So I will just rush so you can. One important point is that they have written this value SGN, called Signum. And Signum, 5 Signum is the input. And he has also written its value in terms of minus 5 plus 10 UT. So I'll just explain a little bit this one. But let's see the frequency domain representation of Signum. Can be represented as 2 over j omega. You could have also converted this individually and you'll get the same answer. I'm just showing here in the green bracket the points to explain what is signum. Now, this type of function is called the signum function. And there are 2-3 methods of representing this. One is, you can see this is minus ut, minus u minus t. And this is ut. So you can say that ut minus u minus t is the function signum t. But here, since he has followed a pattern, so let's see how did he get this. First of all, let's take a value of -1, a straight line all the way -1. But in our case, we have to finish it after this point, no -1. So what we have to do is we have to just add a +1. And so the net result will be something like this. We have -1, but here it is 0. +1, -1, 0. But we want it to be like this. That means we have to add further 1 in whatever we have done here. And that means instead of 1, now we have 2 here. We have to add another 1, so it will be 2 or 2 ut. And so from here we can say that the function is -1 plus 2 ut. And this is what he is saying here, just multiplied by 5. If you multiply this by 5, you get this value. This was just for your knowledge. Now let's solve the question. This is the circuit. We'll apply this formula. So 5 signum t is 5 into 2 over j omega. Signum t is 2 over j omega. That will be 10 j omega. This will be our input. And the inductor will be, we know j omega L. L is 1. That will be j omega. So Fourier domain circuit will look like this. Input 10j. This one is the input, j omega, and this. Remember, we have to find out the output across 4 ohm resistor. And we have written them in capital letters. Capital VI, capital VO. We follow the same technique. VO is Vin divided by this, multiplied by the voltage across which we are going to find out. So multiplied by 4. And from here, we move this to the left-hand side to get H omega. So H omega will be 4 up and J omega plus 4. So we have got H omega. Now we'll just follow the formula that we have learned. This is the formula for V out. V in H omega. We know V in, we know H omega. And so it will V in multiplied by H omega. And solving, we get this form. So there are 2 factors at the denominator. So we have to use partial fraction here also. So A plus the first factor, A divided by the first factor plus B divided by the second term. Residue method, I will not repeat. I'm just going to write down. So you know j omega multiplied by V omega. From here we put 0. That means j omega is equal to 0. V omega is this value. Then j omega gets cancelled. This is left. Plugging in the value of j omega is 0. We get this answer. So A is 10. Similarly, B we multiply by the denominator of B, and solving we get B is equal to -10. Remember, this condition changes. Now this is equal to 0. That means j omega is equal to -4. So A and B we have found. So V omega is this term, plugging in the value. And now we are ready to take the inverse Laplace. Now, 10 over j omega, I'm writing it as 5, 2 over j omega, because we have a formula for 2 over j omega, we go to signum t. So that is why I have broken it down. and the second part remains as it is. So taking the inverse Laplace, this is 5 into signum t in the time domain. We're going. Similarly, this one, we're going to the time domain, e raised to the power minus 80 ut, so 10 e raised to the power minus 40 ut. Now in the book, he has given the value of this was the input signal, 5 signum t minus 5 plus 10 ut. So we will just plug in that value here. So plugging in and solving. So this is our final answer. I hope you have been able to follow this. Please let me know through your feedback. Thank you.